Welcome to Stoichiometry 4, where we will introduce the idea of limiting an excess reagent. A couple of definitions. The limiting reagent is the reactant that is completely used up in a chemical reaction. There will be none left, and it will limit the amount of product that you can produce. You cannot produce any more product than the limiting reagent allows. The term reagent and reactant can be used mostly interchangeably here. Reagent is a generic term for a chemical substance in a chemical reaction. The excess reagent is a reactant that is not completely used up in a chemical reaction. There will be some left over. If you have the exact amount you need of both reactants and products, we are said to be operating under the conditions of stoichiometric equivalent. This is fairly rare in most real processes. If we had been together in class, we would have introduced this idea by making chocolate chip cookie dough, and then we would have eaten the chocolate chip cookie dough because cookie dough is yummy. As a side note, when we do this in class, I do not use raw eggs, primarily because there's a high risk of salmonella poisoning in raw eggs, and so in order to replace that moisture so that we get the right texture on the cookie dough, instead of using eggs, I use an equivalent amount of heavy cream. This makes for some really yummy cookie dough that's not very good for baking, but it's super great for eating. So if you want to have that as a snack, if you have some friends over after the quarantine, for snacks in a movie, you can make cookie dough as one of your treats. So anyway, what we would do is I would have handed out a set of ingredients like you might see in this picture, and then I would say, assuming that you have a sufficient quantity of all of the other reactants, how many cookies can you make based on, say, a canister of salt? And when we look at the serving size on the salt and we look at this recipe, we find out how many teaspoons there are, and we find out that you can make something like 12,000 cookies from a container of salt. But of course, if we only have one bag of flour, you're not going to be able to make 12,000 cookies. You're going to be limited by how much flour you have. Usually the limiting ingredient in a batch of chocolate chip cookies is the chocolate chips. Most people will go out and buy a bag of chocolate chips in order to make chocolate chip cookies. And then once you make those cookies, if you want to make any more chocolate chip cookies, you have to go get more chocolate chips, because at that time in your house, the limiting ingredient is going to be chocolate chips. And so that's the kind of thing that we're looking at here. Generally, when I make a batch of chocolate chip cookies, there is a lot of flour left over in the flour canister. There's certainly a lot of salt left over. There's a lot less, based on the ratio of butter left over, for instance, in your ingredients that you would keep in your house. So this is the idea we're looking at. What do we run out of first, which determines how much actual product we can produce? This is funny, you see, because squash is a vegetable. It's also a sport. Play with a racket. And it turns out it's a way to die. Okay, so here is the reaction that we're going to look at in terms of, in order to sort out limiting reagent. So go ahead and read through this and think about a balanced chemical equation for this process. Pause the video, write that equation. Don't forget your states of matter. So here we are. Here's our chemical reaction. 16 moles of silver solid plus 1 mole of sulfur S8 produces 8 moles of silver sulfide Ag2S. The question here is, what mass of silver sulfide is produced when 2 grams of silver and 2 grams of sulfur are reacted? What mass of which reactant is left unreacted? So there are a couple of different ways to tackle these problems. We're going to look at one now, and then in the next video, I'll kind of break down all of the different ways that you could go about this. But when you're trying to figure out how much product can be produced, one of the ways to go about doing this is just like with the chocolate chip cookie recipe. We're going to assume we have plenty of sulfur and figure out how much silver sulfide we can make from the silver that we have. And then we're going to assume that we have plenty of silver and figure out how much we can make from the sulfur. So my first calculation is going to be silver 2 grams of silver, 2 grams of silver sulfide. This is a grams to moles to moles to grams calculation. And here's your game board for that. You start with 2 grams of silver. We're going to use the molar mass then to convert that to moles of silver. Here's our mole ratio. Again, you could put 1 to 2 there if you want to reduce it. I tend to use the numbers from the equation when I set up my game board just as kind of a standard process. And then we're going to convert that then to grams of silver sulfide with the molar mass. Then I'm going to go over and I'm going to start with my 2 grams of sulfur and figure out how much silver sulfide I can produce. Again, it's a grams to moles to moles to grams calculation. And again, you notice the second half of this thing is going to be exactly the same because we're looking at the same outcome. So what you want to do is multiply across the top and divide across the bottom for both of those game boards. And you're going to figure out which of those produces the lower number. And what we find is that 2.3 grams of silver sulfide is the amount you can produce because that is the lower of the two calculations, with silver being your limiting reagent. You're going to run out of silver first. And so the first calculation produces the 2.3 grams of silver sulfide. The second calculation produces a higher amount, but you can only produce as much product as your limiting reagent allows. Let's look at our next calculation, which is what mass of which reactant is left unreacted. So we know that silver is the limiting reagent, so it's going to get completely used up, and there's going to be some sulfur left over. So we're going to do a calculation from silver to sulfur, grams to moles to moles to grams. And there's the setup there. Again, we're going to take silver and convert it to moles. We're going to take the mole ratio, 1 to 16, and then we're going to convert that to grams of sulfur. And once we get that number, we expect it to be less than 2.0 grams, which is how much we have, and then we're going to subtract that number from the 2.0 grams. And what we find is that there will be 1.7 grams of S8 left over. And so that is your amount of unreacted sulfur. So here's one for you to try on your own. So read through the problem, go through your stoichiometry steps. You need a balanced chemical equation. You need to identify knowns and unknowns. You need to check your map. You need to set up your game board. You need to do your calculations. Again, there are going to be multiple game boards for each problem here when you're dealing with limiting reagent problems. So pause the video, see if you can work through the problem, and then I'll give you a detailed solution when you're done. Okay, so here's my setup, and I want you to notice a few things here. I've written my balanced chemical equation. I'm going to take my given information from the problem. I'm going to write that across the bottom. And then I'm going to write any molar masses that I need, anything where I'm going from grams to moles. I know I need a molar mass, so I'm going to calculate those ahead of time and put them across the top. You don't have to set the problem up this way. This is a way that I tend to tackle the information so I can keep all of the information in front of me in a fairly condensed form. Okay, I want to know how much silver chloride I can produce. So I am going to do a calculation from silver nitrate to silver chloride. That's going to be a gram to mole to gram calculation. I am also going to do a calculation from magnesium chloride to silver chloride, which is also going to be a grams to moles to grams. Those two calculations are both going to spit out an amount of silver chloride I can expect to produce. The actual amount I can produce is going to be the lower of those two numbers. So I'm going to go ahead and set the game boards up for you here and show you the calculations. Again, if you didn't get this far, or if you set the problem up differently and you want to pause the video, see if you can set up the game boards and get the calculations, then you can do that now. So here is your first calculation. Grams of silver nitrate. Molar mass is going to take us to moles. Our mole ratio is 2 to 2. And then converting back to grams of silver chloride. Here's our second calculation, magnesium chloride. We're going to convert that to moles. Here's my mole ratio, and then I'm going to convert that to grams of silver chloride as well. So you want to multiply across the top, divide across the bottom for both of those game boards. Again, if you want to take a pause, correct your calculations if you need to, and do the calculations, feel free to do so. So we get 13.71 grams of silver chloride. In the first calculation, we get 12.7 grams of silver chloride in the second calculation, which means we can only produce 12.7 grams of silver chloride, and magnesium chloride is my limiting reagent. So now to find the amount of excess, you always have to work from your limiting reagent to your excess reagent. We just figured out magnesium chloride is my excess reagent. So I'm going to do grams to moles to moles to grams, magnesium chloride to silver nitrate. Again, set up the game board, take a pause, do the calculations, see what you get. And so here we are. We have grams of magnesium chloride going to moles of magnesium chloride. Here's my mole ratio here. We're going to convert that back to grams. And then that's going to tell you how much of that silver nitrate you're going to use. End up using 15.0 grams of silver nitrate. We have 16.25, so you're going to subtract that 15 from the 16.25. Really, we should round that to 1.3 grams. I didn't do a good job with my sig digs there because we're rounding that, our calculation to the 10th place. So 1.3 grams of excess silver nitrate is a better answer than the one that is on the slide there. And there you have it, calculating limiting reagent and amount of excess reagent.